Hi there and welcome to lesson 8.7 where we are going to be factoring special cases. We'll be factoring perfect squared trinomials and also factoring the difference of squares. So throughout the lesson, as we look at these special cases, we want to pay close attention to the first and the last terms to see if they're perfect squares. And if they are perfect squares, it's going to make factoring really, really easy. Let's take a look. So we got a couple new definitions. You really haven't heard of a perfect square trinomial, nor have you heard of difference of two perfect squares, but they come from something that we already know from lesson 8.4. A perfect square trinomial comes from the square of a binomial. And if you remember, the square of a binomial was when we took something like x plus 5 and it was squared, so we had a binomial squared. So a perfect square trinomial comes from that. And then the difference of two perfect squares, that comes from sum and difference from lesson 8.4. And remember, sum and difference looks something like this, like there was a difference and then we had a sum and we were multiplying them. Okay, so those special cases came from lesson 8.4. Now what we're going to be doing is factoring them. Okay, factoring what their product would be to get it back to a square of a binomial or the sum and difference. Okay, so let's give this a try. I'm just going to switch colors here. So our first perfect square trinomial is right here. X squared plus 6x plus 9. So what we want to do is factor it, get it into its two factors. So I'm just going to start out by writing what those factors would look like here. Now, what we want to pay close attention to or look for are perfect squares in the first and the last terms, because that's going to make it really easy to factor. And you're going to notice that with these special cases, there's going to be a perfect square in the first and the last terms. X squared is a perfect square. It's x times x. So that x times x is going to be the first term in each of the two factors. And then the last term is also a perfect square. Square root of 9 is 3. That's going to be the last term in each of the binomials. Now we need to decide, are these going to be plus or minus? We'll look at the middle term here. This is a positive 6x, and we also see we have a positive 9. So they're going to both be pluses. Now remember, I told you that it comes from a square of a binomial. So this was the binomial of x plus 3 squared, right? Now I don't need to write my answer like that. I could, or I could just leave it x plus 3 times x plus 3. Either way, I'll just actually leave it on there just so you can see it both ways. Either way would be fine. Those are its factors. All right, let's try another one. Here's another perfect square trinomial. So with this one, we're going to do the same thing. We're going to get ready to write the factors. Look at the first and last terms. Notice that they're perfect squares. That's going to be really helpful. The square root of x squared is x, and the square root of 16 is 4. Now, all you need to decide are these going to be pluses or are they going to be minuses? So when you look here in the middle, negative 8x, remember that these last terms have to add to get the middle term. So they're both going to have to be negative 4. Remember, it also comes from the square of a binomial. So they should be the same because this came from x minus 4 squared. You could write the factors either way. You could write it x minus 4 times x minus 4, or you could write it x minus 4 to the second power. Either way. Okay, so those were our perfect square trinomials, and we were able to factor them into a square of a binomial. Now let's take a look at our special cases down below here, the difference of two perfect squares. Now remember, this came from sum and difference. So here we've got x squared minus 36, and we're gonna factor this. I'm just going to get ready here. Now look at the first and the last term. Do you see how they're perfect squares? We always want to be looking for perfect squares in the first and the last terms. So square root of x squared would be x times x, and the square root of 36 is 6 times 6. Now do you see how the middle term's missing from this trinomial? There's no middle term. And that's because this came from a sum and a difference where the middle term canceled out. So that means that one of these has to be plus and one of them has to be minus. And if you were able to FOIL this out, you'd see that it would be a negative 6x plus 6x in the middle that would cancel out to make 0. So that would be the factored form of this difference of two perfect squares. And that comes from the sum and difference. Let's try another one. This one. Okay. So getting ready to factor. Notice that it's missing the middle term also. We'll look at the first and last terms. They're perfect squares. The square root of 4x squared would be 2x. And the square root of 25 is 5. Now the middle term canceled out because this comes from a sum and a difference, where one of them is a plus and one of them is a minus. Now, how could you check? How could you check that when you factored each of these examples that you actually factored them correctly? How could you check that? Well, the answer to that would be FOIL. Okay, you could FOIL and you could check that you get back to the original polynomial that you were factoring. That's one way that you could check your answer. Okay. All right, let's go ahead and we'll go through some examples here. So we're going to do 2 examples from square of a binomial. So when I get ready to start factoring this, one thing that I could be thinking about is that first and last term. Do I see the first and last term as a perfect square? Yes. So that's going to help me factor. I'm getting ready to factor here. So square root of x squared would be x times x. And the square root of 4 is 2 and 2. Okay, well, the middle term here is a minus 4. And we know that these two have to add together to give you that middle term. So they both must be a negative. And also you can see negative 2, this negative 2 multiplied by this negative 2 gives you that last term of positive 4. Now I could always FOIL and I could check my work. That's always something that I could do. In fact, I recommend doing that. But I'm just for the video here, I'm just going to go with this. Now I could write my answer like this, or I could write my answer as x minus 2 squared, because remember, this comes from square of a binomial. So the answer could be written in either form. All right, let's try one more. So here, getting ready to factor into 2 binomials. Look at the first and last terms. They're perfect squares. So if I take the square root of the first term, here take the square root of the last term, that's 8. Now the middle has got to add to equal 16. So these got to both be plus. So here I've got it. Now I could also write the answer as x plus 8 squared, because that's another way of writing x plus 8 times x plus 8. Okay, so those are from square of a binomial. Let's look at a couple from sum and difference. Now, do you see how the middle term canceled out on this? So this comes from sum and difference, right? When you got 1 plus and 1 minus. Okay, so getting ready to factor, I see that the first and last terms are perfect squares. Super helpful. Square root of x squared. Square root of 81 is 9. Okay, middle term canceled out. Even for these two to multiply together to give you that last term of 81, they'd have to be opposites. One would have to be positive, one would have to be negative. Okay, so now if you FOILed this answer, like if I FOILed the x plus 9 times x, or x minus 9, sorry. If I went ahead and FOILed this, do you see those middle terms? They cancel, don't they? So you end up with x squared minus 81. Okay, so FOILing is a nice check. I'm just kind of checking to be sure that my factoring worked. But this is from sum and difference, where those middle terms canceled out when you have a plus and a minus, and they're exactly the same. That's where that's from. Okay, so let's do one more. All right, here's this one. Ooh, leading coefficient of 49. Doesn't look so fun, right? You might think, do I need to use that trick? But no, if you see that it's a perfect square in the first term and the last term, it's a special case, and you can use the square root here to help you out. Square root of 49x squared would be 7x. And the square root of 1, remember, that's just 1. 1 times 1. Middle term canceled out. They must be from a sum and a difference. So here's the factored form. And again, if you want to, you could FOIL to check. That's always a great check. Okay, you could FOIL it and see, does it get me back to the original polynomial? Okay, well, little application question here. Find the length and width of the square. So we know that length and width should be exactly the same. If this is the area, we can take this polynomial and we can factor it in order to find the two factors here that are going to be the length and width. Now, they should be the same because it's a square, right? And length and width should be the same. Now, notice the leading coefficient is 9. And you might be thinking, oh, do I have to use that trick where I take the first and the last term and multiply them together? No, no, no. If you see that the first and the last terms are perfect squares, you can use that to help you. The square root of 9x squared is 3x times 3x. And the square root of 16 is 4. 4 and 4. Now, this is a square. These two should be the same. So they should be both pluses, right? Because this came from that special case polynomial. Okay, so if I say that the length and the width are 3x plus 4, let's just check it. If I take 3x plus 4 times 3x plus 4 and I multiply them together, it should take me right back to this area. So I'm just going to quick check it. This would be 9x squared plus 12x plus 12x plus 16. Well, what do you know? The middle term doubled there. 9x squared plus 24x plus 16. And I get right back to the area by multiplying length and width. So that leaves my answer here for my length and the width to be 3x plus 4. So length equals and width equals 3x plus 4. Okay, let's go ahead to our summary. So when we're looking at special cases, in fact, any polynomial, always check for this. Always look at the first and the last terms, see if they're perfect squares. Because if they are, it can be really, really helpful to factor. Take a moment if you need to copy down the summary so you can use it later. And thank you so much for joining me for Lesson 8-7. Have a great day.